All right, hello. I'm going to review the stuff we went over yesterday just in case you were in a class that didn't get to everything, and then we'll start going over new stuff. So make sure we copy down these two learning goals for 8.1. Check that in your binder, pause it, just double check that it's there. All right, welcome back from your pause. We're going to look at this diagram. Remember we said we were at a skate park with a ramp, and we had to find some parallel lines, perpendicular line segments, and some parts that are neither parallel or perpendicular. So, in class we said we have to think about this as a 3D shape, but on a 2D surface. So if we just highlight real quick, we know that these two lines were parallel. So we would say BE is parallel, not BE, sorry. BD is parallel to EF. We also said that BE was parallel to DF. That's all the ones that we said we could find without knowing what points were on the back of the ramp. Next up we did perpendicular. So we said a lot of these angles were perpendicular, like the one I just highlighted, some of which were BC and CD. If we think about it as a 3D shape, BE and BC, we could even see if it's a 3D shape, BE and BD. Again, that's if we're thinking about this as a 3D shape, that surface probably has a right angle there. So lastly, we have to find angles that are not parallel, but also not perpendicular. So that's just any angle that, an angle that exists that's not perpendicular. So that would be like the ones I just highlighted, BA and CA, or BC and BA, and etc. So we can keep going on through the list. So we also looked at the the formula for slope. We did our do now on that. It's also over here. This question kind of asks explain why the slope can be calculated. That's because we know we want rise over run, which is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So that's kind of why it's like that. So some of our classes did this diagram specifically for 3A and 3B. We had different ones in my book versus your book. So if we look at this, WU, I'm sorry, I think you have VU in your book. VU is this line segment right here, which we go up 1 over 3, so that has a slope of 1/3. WV is this line segment right here, which again is up 1 over 1, so again 1/3. And it says, why do the slopes of VU and WV, why are they equivalent to XT? So first let's look at XT. XT is right here. We know that these are equivalent because they are all on the same line. All right. Next up, the book wanted us to find some slopes of some more specific line segments in our diagram. So we have AB is this line right here. We could find a part of it. So we can go up 1 over 3, up 1 over 3, or we could use the coordinate. So this one would be negative 12, 0, 0, 4. So we would have 0 minus negative 12 over 4 minus 0. So we get 12 over 4 did that backwards, right? Because we need y's on top. So we would have 4 minus 0 over 0 minus negative 12. So we get 4 over 12. So we get 1/3. So we can either get 1/3 using rise over run or actually using the coordinates of any 2 points on that line. Xt. We already found the slope for that. That was all of these. So we know that's also 1/3. WG, which is this magenta line right here, we can do our rise over run, which was -3 over 1, so our slope is -3. TJ, which is this line right here, let's run 1 to the right, down 3. So again, that's -3 over 1, which is just -3 if we simplify it. AD, which is this whole line right here, that would be 0 over, I think we said in class, that's -18, so we can simplify that to just 0. Then I added in one last one, which was F, BC, and we said the slope of that, this line right here, was 4 over 0, which we can't do, so that's undefined. So if we read the next part, it says complete the chart on the next page, whether or not the segments appear to be parallel, perpendicular, or neither. I think some of us left class yesterday a bit confused about how they relate to each other. So we said AB and XT. AB, XT. Those appear to be parallel. So let's write that in. Parallel. If we look at WG and TJ, that's parallel. XT and WG, those appear to be perpendicular. XT and TJ, again perpendicular. AB and AD are neither. We would just call those intersecting. And WG and AD, we can't see right away, but if we continue that line down, they do not look perpendicular. So again, that would be a neither, which we could just call intersecting. So now if we look at the slopes, these were 1/3 and 1/3. These were -3 and -3. These were -3 and +1/3, 1/3 and -3. AB and AD was 1/3 and 0. WG and AD was -3 and 0. So if we look for our patterns now, right, parallel lines appear to both have the same slope. So parallel segments, or lines have the same slope. And that's also what we said, that same lines or line segments, if they're on the same line, also have the same slope. Perpendicular lines have slopes that are, and if we look at our two examples, we have -3 and 1/3 and -3 and 1/3 again. And those, if we multiply them together, would give us -1. Another way to think about it is if we flip the third, we get +3. And if we make it the opposite sign, we get -3. So we can call these opposite reciprocals. which means flip the fraction and change the sign. Segments that are neither parallel or perpendicular have slopes that are neither the same nor are opposite reciprocals. So if we look at do your conjectures you wrote in item 6 apply to lines as well as segments, yes. Since segments can be extended into lines. Are all horizontal lines parallel? Use slope to explain how you know. So pause the video, think about this for a second. All right, welcome back. All horizontal lines have the slope of 0, right? Which just means they run and never rise. So that means they are all, they all have the same slope. They all have the same slope, but as we talked about yesterday, just because two things have the same slope doesn't mean they're parallel, because we could have this horizontal line and then, just to be difficult, a horizontal line right on top of it. So for convenience, we can just say we will never have lines that are on top of each other, and if we say that, then they are all parallel. So if we have lines that are different, but they all are horizontal, then they are all parallel to each other, right? And we can see that on the paper I'm drawing on, right? This horizontal line is parallel to this horizontal line, which is parallel to this horizontal line. All these horizontal lines are parallel, right? We wouldn't want horizontal lines to intersect, so we need them to be parallel. If we look at number 9, JK has a slope of 2/5, MN has a slope of 5/2. We want to figure out which one is it. Is it parallel, perpendicular, or neither? And explain your answer. So pause, pick a choice, try to explain it to yourself, and then come back to the video. All right, welcome back. We want to compare these two fractions. Are 2/5 and 5/2, are these two slopes, would that mean the lines are parallel, perpendicular, or neither? We can rule parallel out right away. So 2/5 is not equal to 5/2. Not equal, so they're not parallel. Perpendicular, we want them to be opposite reciprocals, right? Perpendicular. We want them to be opposite reciprocals, which means if we have 2/5, to make it the opposite reciprocal, we need to flip the fraction, so 5/2, and then make it the opposite sign. This is the negative 5/2 is the opposite reciprocal of 2/5. Do we have 5/2? The answer is no. We have 5/2, not negative 5/2. So these are not perpendicular, so the only choice left is neither, which again we keep calling intersecting. These two lines with these slopes, 5/2 and 2/5, would intersect, but they would not intersect at a 90-degree angle. So if we look at the 8-1 practice real quick, we did this for our do now yesterday. We found that this slope for AB, we said was 2/3. The slope for AD was -1. And the slope for DC was +1. So now if we look at what the book is asking, we want to know if AB and DC are parallel. If we look at AB and DC, we can imagine that the lines keep going on. and we can kind of see how they keep getting closer and closer together. But we can also use their slopes. We have the slope of AB is 2/3. The slope of DC was 1. Those are not the same number, so they are not parallel. If we look at 11, AB is that perpendicular to AD. So again, we look at the slopes, 2/3 versus -1. We have to ask ourselves, is that the opposite reciprocal? AKA, if we flip the fraction and make it the opposite sign, do we get the other slope? The answer here is if we flip the fraction, we get 3/2, which is not equivalent to 1. Although they are opposite signs, they are not reciprocals. So those two lines are not perpendicular. The last one we need to check is AD versus DC. Are those perpendicular or not? We can look at the fractions. Well, here we don't have fractions. We can make them fractions. So we have -1/1 and 1/1. They are opposite. We have a positive and a negative, and they are reciprocals because if we flip 1/1, we get 1/1. So those are perpendicular. All right. 13 is looking at a new kind of picture. It says line L passes through the origin and the point 3/4. What is the slope of the line parallel to L? So first we need to find the slope of L. The origin is always 0, 0. We have our second point, 3, 4. So to find the slope, we can just use our slope formula. So 4 minus 0 are our 2 y's. 3 minus 0 are our 2 x's. So we get 4/3 for our slope. So it says, what is the slope of the line parallel? We need to remember what we said about parallel lines. We said parallel lines or segments have the same slope. So we can answer this question now. The slope of a line that is parallel to line L also has M, aka the slope of 4/3. All right. Lastly, it says angle RST is a right angle. If RS has a slope of 3, what must the slope of ST be? So we know RST is a right angle, but we also know the slope of RS is 3, which means it's positive, it's kind of steep. This has a slope of 3. It's then asking, we know there's a right angle, so let's put some points here. We have R and S. We have to draw ST so it's a right angle, but we need to figure out what is the slope. So these are perpendicular lines because they form a right angle. So pause the video and try to find what is the opposite reciprocal of +3. All right, welcome back. If our slope is 3, we can rewrite that as a fraction as 3/1. If we want to find the opposite reciprocal, we have to first flip the fraction, so we get 1/3, and we have to make it the opposite, so change the sign. So our slope, the opposite reciprocal, should be -1/3, and that would make it perpendicular. So this is the first video. It was just a recap of 8.1.